Nature conceals many mysteries. From recurring patterns and events in nature, mankind is always in a continuous pursuit to identify and name these patterns. Fortunately, math is an accommodative tool that allows mathematicians and scientists to study these patterns. Throughout the course of history, many mathematical constants have been discovered. Constants are numbers that have a set value determined by an unambiguous statement. The first ever constant to be discovered was, of course, the number 1. This constant denotes the presence or beginning of one object. Without 1, you cannot have 2, 3, 4, and so on. The next fundamental constant to be discovered was 0. 0 was discovered when ancient people used blanks or placeholders to display an absence of a number or value in a certain location. 0 is an important constant because without an initial absence of an object, you cannot have its existence. This means that without the presence of 0, you cannot have 1, 10, 100, and so on. Humanity decided to take it up a notch in later times when they started discovering irrational constants. In ancient Greece, one of the famous mathematicians, Archimedes of Syracuse, discovered the irrational constant pi by approximating the area of a circle. He accomplished this by using the Pythagorean theorem to find the areas of two regular polygons, one inside a circle and one outside. The values of the areas of both the polygons gave the minimums and the maximums for the actual area of the circle in between them, so Archimedes was able to come up with an approximation of the value of pi, with the first few values being 3.14159. Don't try to go any farther. A similar approach was also accomplished by a Chinese mathematician known as Zhu Zhongzi. He performed a similar method but used an extremely precise polygon, which was speculated to have about 12,288 sides. Zhu's value of pi was accurate to 6 decimal places, an accuracy unmatched for the next thousands of years. Pi is also found in nature, outside of circles as well. Pi can be used to calculate the spiral of the DNA's double helix, the embryo formation and pattern developments in animals, the probability of a needle crossing a set of parallel lines, and the electrostatic field equation constant K, which is 1 over 4 pi epsilon naught. Another constant was discovered by Jacob Bernoulli in 1683, who tried to find the value of the limit of 1 plus 1 over n to the power of n, where n extends to infinity. This value is equal to the constant e and appears in compound interest and natural logarithms. In nature, e appears in the spiraling pattern known as a logarithmic spiral. This spiral appears in the arms of spiral galaxies, the bands of tropical cyclones, and a variety of shell structures found in mollusks. E is also used in half-life calculations where t half equals ln 2 over k. Perhaps one of the most interesting constants is I, which technically does not even exist. I is an imaginary constant equal to the square root of -1. This value technically does not exist and has no real tangible value. When you add I to a real number, you get a complex number in the form of a plus bi. Complex numbers can be graphed in the complex plane where the y-axis is replaced by the imaginary axis. Even though this constant has no real value, this constant still has applications in the real world. In electrical engineering, I is used to find the impedance of a current. In nature and art, imaginary numbers appear in fractals. Fractals are geometric shapes that will always contain detailed patterns at infinitely small scales. They exist in real life, in snowflakes, lightning, mountains, and more. Benoit B. Mandelbrot discovered a famous fractal set that he would later term as a Mandelbrot set. It is a set of complex numbers C, for which a sequence Zn plus 1 equals Zn squared plus C, where Z naught equals 0 plus 0i. This equation generates a Mandelbrot set pattern in the complex plane. So, now we have explored some of the most fundamental and famous constants that are found in nature. But what if there was an amusing equation that tied these 5 constants together? Take these two functions, g of x and h of x, where g of x is equal to e to the power of negative I theta, and h of x, which is equal to cosine theta plus I sine theta. Then take the function f of x, which is equal to g of x times h of x. Take the derivative of f of x, and using the product sum method, we get g prime of x times h of x plus h prime of x times g of x. G prime of x is equal to negative I e to the power of negative I theta, and h prime of x is equal to negative sine theta plus I cosine theta. Factor out e to the power of negative I theta, simplify, and you will cancel out the trig identities, which means that the derivative of f of x is equal to 0, which indicates that this whole function is a constant. To find the constant, we set the function equal to c and plug in 0 for theta, and then solve for c. C is equal to 1, so we simplify to e to pi I is equal to cosine theta plus I sine theta. And when we plug in pi for theta, we get e to pi I is equal to cosine pi plus I sine pi, which simplifies to e to the pi I equals negative 1 plus 0, which simplifies again to e to the pi I plus 1 equals 0. This famous equation was derived by Leonhard Euler. This equation unfortunately has no application and does not occur in nature, but it is appropriately termed as the most beautiful equation in math because of the unification of 5 fundamental constants in one equation. So now we learned 5 of the most fundamental constants in math, and proved an equation that unified all 5 constants together, just for fun. So there you have it, 5 fundamental mathematical constants in a video under 10 minutes. Have a great day.